Welcome to section 7.4, completing the square and solving quadratic equations by completing the square. So we're mainly going to use this section to develop the quadratic formula. So in order to do that, let's again review what it means to complete the square. So right here what we have are a few perfect square trinomials. All right, so the first one is some definitions we have from our factoring chapter. And here's one for x plus 4 all squared. And what we're going to be focusing on is the relationship between the middle term and the constant. And I should actually say the middle coefficient. So the relationship between the middle coefficient and the constant term. And notice, and we can kind of see it in this formula, if we take our middle coefficient, 2a, if we divide it by 2 and square it, we get back to the constant. So 2a, if we divide it by 2 and square it, we get back to a squared. All right, and it also works down here with real numbers. 8 divided by 2 is 4, and if we square 4, we get 16. Okay, so all perfect square trinomials have this form, as long as your leading coefficient is 1, I should say. Okay, so this is how we're going to complete the square. So again, let's say we had x squared plus 8x, and we wanted to figure out the constant we need to complete the square. We're going to take that middle term, always divide it by 2, always square it. All right, so 4 squared is 16. And now the perfect square that it factors as, sometimes we can just look at it and figure it out. Like x squared plus 8x plus 16 is x plus 4 all squared. Alternatively, when we divide the middle term coefficient by 2, in other words, when it's 4, that's how we're going to complete the binomial. So x plus 4 all squared. Okay, so let's see how we can use this completing the square to solve quadratic equations. Let's say we wanted to solve x squared plus 6x equals 1. And notice if we were to use our old-fashioned method, if we were to subtract 1, so this could just be some side work. Also now we know why it's different from the previous section. If we subtract 1 and make one side 0, we would need two magic numbers to factor this that multiply to -1 and add up to positive 6. And there are no such numbers. So this method doesn't work. This method has limitations. So that's why we're completing the square right now. Okay, so let's rewrite this. We're going to complete the square on the variables, so the x squared plus 6x. So we have to figure out the constant. Let me write it in a different color. We have to figure out the constant that makes x squared plus 6x a perfect square. All right, and then we'll just balance our equations. So whatever we add to one side, we'll add to the other side. So perfect square trinomials all have the same form. We take the middle term, positive 6, divide by 2, and square it. So 3 squared is 9. So we're going to add 9 to both sides. Okay, and then x squared plus 6x plus 9 is going to factor as x plus 3 squared. Okay, and then on the right, 1 plus 9 is 10. All right, and again, x plus 3 all squared, either we can look at x squared plus 6x plus 9 and figure it out, or after we divide the middle term by 2, that 3, that's what goes in the second part of the binomial. Also, we can look at the constant, and it's the square root of the constant. All different ways of looking at this. Okay, so look at this. We completed the square. We have x plus 3 squared equals 10. Now we can actually use our square root property and solve this. We can take the square root of both sides, and we have x plus 3 is equal to plus or minus the square root of 10. That's our square root property. We'll finish it out by isolating our x, subtract 3 from both sides, and there's our solution, -3 plus or minus the square root of 10. Okay, so let's look at this example then. And actually this example is developing our quadratic formula. So we're going to be solving any quadratic equation, ax squared plus bx plus c. So first of all, equals 0. So we're finding values of x that make this true. First of all, we can only complete the square when our leading coefficient is 1. And right now it's a. So our first step is to come in and divide everything by a. Okay, and you can separate that out. So it's like dividing each term by a. So we get the following. We get, let's see, a divided by a is just x squared plus b over a, x, plus c over a, and then 0 divided by a is just 0. Okay, so now we're going to complete the square on this. So in our previous example, we put the constant on the other side just so we don't have to worry about it till the end. So let's do that again. All right, we're going to add a constant at the same time to complete our perfect square. Okay, and how we do this is always the same. We're going to take that middle term. We're going to divide it by 2. And we're going to square it. So we're going to have to use our exponent rules and distribute that exponent to all of our terms, and it ends up being b squared over 4a squared. And now whatever we do to one side, we do the other. So we're going to add b squared over 4a squared. Okay, and then while we're at it, let's combine our fractions on the right. So we need a common factor of 4a squared. So negative ca, we're going to have to add a 4a to the top and the bottom. So to add fractions or subtract fractions, we need a common denominator. And so now we have that 4a squared on the bottom. Okay, so we have negative 4ac plus b squared over 4a squared. And I'm just going to rewrite this so the positive number comes first. So b squared minus 4ac over 4a squared. Okay. And then on the left, going all the way back up here, we just created this perfect square trinomial. So let's factor it like that. And so it's going to be x plus something squared. And remember, it's whatever the middle term is divided by 2. So it's going to be b over 2a squared. All right, now we're ready to take the square root of both sides. To solve for x, remember we're trying to find solutions for x. And we have x plus b over 2a is equal to plus or minus the square root of the right-hand side all right, and then we're taking the square root of the numerator and the denominator, and notice the denominator is a perfect square. The square root of 4a squared is 2a. Okay, final step is subtract the b over 2a from both sides. Okay, and then look at that. We have the same denominator. So the solutions for any quadratic equation is going to be this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and then that brings us to section 7.5. 7.5, we're looking at the quadratic equation. And that's exactly what we just proved. So we're going to be using the quadratic formula now to solve quadratic equations. So we just showed that the solutions to ax squared plus bx plus c equals 0 are this. And this is something to memorize. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I have included links to help you memorize this formula. Some people like to do row, row, row your boat, or pop goes the weasel. So whatever you need to do, just memorize it. All right, so let's solve using the quadratic formula. We have 2x squared plus 5x minus 2. So we have our a is 2, our b is positive 5, and then our c is negative 2. So the quadratic formula says our solutions are x is equal to the opposite of b. So the opposite of b is negative 5, plus or minus the square root of b squared minus 4, and then parentheses are important. A is 2, c is negative 2. There's 4ac all over 2a, and a is 2. Okay, so that's how we plug it in. Let's see how we simplify it. So 5 squared is 25. 4 times 2 is 8 times negative 2 is negative 16. So minus a negative 16 is plus 16 all over 2 times 2. Okay, so 25 plus 16 is 41. No perfect squares in that, so we're going to leave it. It's completely simplified. And then we're going to divide it by 4. And that's your solution. Just to note, in your textbook, when you guys do your homework problems, they're going to ask you for the exact and the approximate solution. This is the exact solution, the one that contains the radical sign. And then if you wanted to round, that would give the approximate. And you can do that via calculator. So take out your scientific calculator to make sure you can do it correctly. All scientific calculators are different. Remember to obey order of operations, but you would get that x is approximately 0.3508 and negative 2.8508. Okay, so again, you do it twice on your calculator. One time you add root 41, the other time you subtract the square root of 41. Okay. All right, so let's do some more examples on our own. These ones are a little bit different. This first one, you have parentheses. Now, working with parentheses is really hard in the quadratic formula. So what's one thing we can do to get rid of parentheses? Multiply all terms by the least common multiple. In this case, the LCD, least common denominator, which is 6. So multiplying both sides by 6 is an allowed operation. And let's see what happens when we clear them. So we can clear as we go. And when we multiply the first term by 6, 6 over 3 is 2. And then 2 times 2 is 4. Next, when we multiply the second term, 5 6 by 6. 6 divided by 6 is 1. So that cancels. And then 1/3 times 6 is like 6 over 3. Okay, so now let's work with this one. This one is much easier to deal with. So with the quadratic formula, and especially when we see that middle term, 5x, we're going to make one side 0 just like before. That's our strategy again, when we have that middle term 5x. And now we can do the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And now it's time to simplify. And there's your solution. Okay, so this next one is a little bit different. We have 2 factors equals 1. So just like we saw before when we're solving quadratics, we have to make one side 0. And the only way to do that is to multiply and FOIL out 3x plus 2 times x minus 1. And then subtract 1 from both sides to make it 0. And now we can do our quadratic formula. So again, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's see what we have. So 1 plus or minus the square root of 1 plus, let's see, that would be 36. 4 times 3 is 12, times negative 3 is negative 36, so negative negative makes a positive. Ooh, and I wrote 2a. I should have wrote 2 times 3 is 6. All right, so 1 plus or minus 37, square root of 37 over 6. And then that's your solution. Okay, so let's come down and talk about the discriminant now. So first of all, we know that the solutions to ax squared plus bx plus c equals 0 correspond to the x-intercepts of ax squared plus bx plus c. So remember, we talked about, let's draw 3 cases. We know the graph of ax squared plus bx plus c would look like a parabola. So we have a couple options when we're talking about solutions. 2 x-intercepts is 2 solutions. 1 x-intercept is 1 solution. No x-intercepts is 0 solutions. So looking at our quadratic formula, the thing that, or the part that's going to determine if we have 2, 1, or 0 is this part, the part we're plussing and minusing. So that part's really important. So we're going to take the b squared minus 4ac, and it gets its own special term. It's called the discriminant, and it determines the type and amount of solutions. For instance, if b squared minus 4ac is greater than 0, we're going to get 2 real solutions because we're going to have to add that and subtract it. So in this first case, we get 2 real solutions. Real number solutions is what I mean by that. Furthermore, if b squared minus 4ac is a perfect square, we actually will get rational solutions, and it also means we can factor a squared plus bx plus c. So that's a powerful result. If b squared minus 4ac is a perfect square, we can factor. And we can actually factor and solve using the zero factor property. All right, so there's a powerful way to let us know if we can factor a trinomial. Okay, next we have if the discriminant is 0. So if it's 0, if we add 0, subtract 0, we're going to get the same number. So we're going to get one real solution in this case. And that's that middle example up above, 1 x-intercept. And it's still rational. B squared over 4ac will be a rational number, no radicals in it. It also tells us we can factor. So again, another powerful result. Finally, if b squared minus 4ac is less than 0, now we're trying to take the square root of a negative number, and we know that's not allowed. So that's when we don't have any x-intercept. There's 0 real solutions. So let's look at an example using the discriminant. So how many solutions are there to the equation x squared minus x minus 12 equals 0? Well, this isn't asking us to solve it, so the instructions are important. How many solutions? So we can solve that using the discriminant. All right, so b squared minus 4ac. Let's see, negative 1 squared is 1. Negative 4 times negative 12 is 48. So we're looking at 49, which is greater than 0. So since our discriminant is greater than 0, we know from above that there's 2 real solutions. In addition, we have a perfect square, so it's not just real, they're also rational. So we could say 2 real or rational solutions. Okay, so let's start summarizing everything we know about quadratic equations, because we have the zero factor property, we have the square root property, and now we have the quadratic formula. So when do we use what? So first of all, we can always use the quadratic formula, okay? And to start off, let's make one side 0. So ax squared plus bx plus c equals 0. It's a quadratic equation. So we have 3 cases. The first case is if after we make one side 0, ax squared plus bx plus c, if it can be factored, if this can be factored, you are going to factor it and use the zero factor property. So in other words, set both factors equal to 0. Sometimes we can look at an equation and know we can factor it. Sometimes we can use the discriminant. If it's a positive square or 0, we can factor it. All of these things. We saw another case is if only we have a squared variable or term, no middle term, in other words, we will use the square root property. And to do the square root property, we actually do the opposite of what we were doing before. We isolate the squared term. And then we say x is plus or minus k. Excuse me, square root of k. We also have something a little bit more complicated. Sometimes it's something in parentheses squared. So I'll just make up something. And then we still use the the square root property and take the square root of both sides. Okay, so if we make one side 0 and we can't factor it, if there is a middle term in addition to the square term, in essentially every case of quadratic equations, we can always use the quadratic formula. All right, so now we have some nice strategies of solving our quadratic equations.